Now we'll discuss this one, how to find a basic feasible solution of the equation 2x1 plus 6x2 plus 2x3 plus x4 is equal to 3, 6x1 plus 4x2 plus 4x3 plus 6x4 is equal to 2. Now this given system of equation can be expressed in a matrix form Ax is equal to B, where A here is this matrix, where the first column represents the coefficient of x1, 2, 4, the second column 6, 4 represent the coefficient of x2, the third column represents the coefficient of x3, that is 2, 4, and the last column represents the coefficient of x4, that is 1, 6. And x here is a column matrix of x1, x2, x3, x4, since there are four independent variables in this case. And B here is this one, 3, 2. Now this matrix A is of order 2 cross 4, that is there are 2 rows and 4 columns. So therefore the rank of this matrix is equal to 2, because the number of maximum independent column also will be 2. So this is from the properties of matrix. So the rank of this matrix A now will be 2. Now from this original matrix A, you can obtain a basic matrix, square submatrix, or the basic matrix. So from this one we can obtain a basic matrix of order of rank 2, that means of 2 cross 2, that is 2 rows and 2 columns. So the first one you can consider from here is this one, by considering the first column and the second column, that is 2, 6 and 6, 4. And then the next one is consider the matrix this one by taking the first column and the third column. So it will be 2, 6, 2, 4. And then the next one is consider the first column and the last column. So it will be 2, 6, 2, 6, 1, 6. Next, consider the second column and the third column. So you'll get 6. This another basic matrix will be 6, 4, 2, 4. The next one, consider the third column and the last column. So you'll get 6, 4, 1, 6. And the last one will be this one. You consider the third and the fourth column, that is 2, 4, 1, 6. So from this matrix A here, you can obtain 6 square submatrix, which are the basic submatrix, because since rank of A is 2, so you have to consider a square matrix of order 2 cross 2. So those 2 cross 2 basic matrix that has been obtained from A are the following. This one, this, and the last one is 2, 1, 4, 6. So from here we'll find out what will be the basic feasible solution of the given equation. So case 1, let us consider this B bar to be the basic submatrix, which is this one, the first one, 2, 6, 6, 4. So consider B bar is equal to this one. Now here you'll see that what are the variables that are not associated with this basic matrix B bar. Since in B bar we consider this matrix 2, 6, 6, 4, where we obtain this matrix B bar by taking only the first and the second columns. That means the variable x1 and x2 here are the variable x1 and x2 are the variables that are associated with the matrix B bar. Then x3 and x4 are not the variables that are not associated with the basic matrix. So here we have to take this one, x3, x4 are the variables that are not associated with B bar. Since we obtained this matrix B bar by considering the first and the third column, and the first column represents the coefficient of x1 and the second column represents the coefficient of x2. So x3 and x4 are the variables that are not associated with the basic submatrix B bar. So in this case you put these variables which are not associated to B bar as x3 is equal to 0, x4 is equal to 0. Now you solve this one. B bar x1 equal to what is B is equal to B, that is 2, 6, 6, 4 into what is x1, what are the variables that are associated with this B bar? It is x1 and x2. So x1, x2 equal to what is B bar? B bar is equal to 3, 2. So we'll write here equal to 3, 2. Now on solving this equation, you simplify, multiply this one, you'll get 2, 6 into this one will give you 2x1 plus 6x2 is equal to 3. Next, multiply the second row with this one. You'll get, name this as equation 1. And this multiply this one with this, you'll get 6x1 plus 4x2 equal to 2. Name it as equation 2. So let us, on solving this equation 1 and 2, first you multiply this equation 1 by 3. Then what will you get? If you multiply equation 1 by 3, then you'll get 6x1 plus 3 into 6 here, it will become 18. 18x2 is equal to 3 into 3 here, it will be 9. So it will be 9. Name it as equation 3. Now, equation 3 minus equation 2 will implies what? So what is equation 2? It is 6x1 plus 4x2. Here also in equation 3 I have 6x1. So if we subtract this equation 2 from 3, then 6x1 will be cancelled. So now 18x2 minus 4x2 will become 14x2 is equal to, what is 9 minus 2? This is 9 here. 9 minus 2 will become 7. So this will imply that x2 is equal to half. Now putting x2 is equal to half in equation 1. So what is equation 1? It is this one, 2x1 plus 6x2. So it will be 2 into x1 plus 6 into half is equal to 3. So this will be cancelled. It implies that 2x1 plus 3 is equal to 3, which means that x1 is equal to 0. So therefore, the basic solution here will be given by x1 is equal to 0, x2 is equal to half, and the non-basic, that is the variable x3 and x4. So x3 is equal to 0, x4 is equal to 0. Now this one is a basic feasible solution. Why? Because all the values of xi are either greater than or equal to 0. None of them are negative. Also, the above basic solution is a basic feasible solution. Since all xi, I varies from 1, 2, 3 up to 4, that is x1, x2, x3, x4 are greater or equal to 0. So since none of them is negative, so it will also be a basic feasible solution. Now you have to note down also, since one of the basic variable in this case, the non-basic variable are x3 and x4, but the basic variable are x1 and x2. It is also a degenerate solution. Why? Because since one of the basic variable, since one of the value of the basic variable is equal to 0, that is x1 is equal to 0. Since one of the basic variables here is equal to 0, therefore the solution is not only a basic feasible solution, it is also a degenerate solution. So this proof that from this case 1, we are able to show that the first solution is a basic feasible solution, and it is also a degenerate solution. Now let us consider that case 2. By considering b bar is equal to 2264. So 2264 is obtained by considering the first column and the third column. So that means the basic variable in this case will be x1 and x3, and the non-basic variables will be x2 and x4. So therefore here x1, x3 are the basic variables, and x2, x4 are the non-basic variables, because this column x, the coefficient of x2 and x4 are not associated to this submatrix B bar. Therefore, they are the non-basic variables. And also, since x2 and x4 are non-basic variables, so you put x2 is equal to 0, x4 is equal to 0. And then solve this one equation, b bar x2 here is equal to that 3, 2, that is b, where x2 here is equal to what? X2 will be consist of the column matrix which consists of the basic variable x1, x3. So if you solve this one, b bar x2, that is 2, 2, 6, 4 into x1, x3 equal to 3, 2. What we are getting from this equation now, you get 2x1 plus 2x3 is equal to 3. 6x1 plus 4x3 is equal to 2. Name this as equation 4 and this as equation 5. Now you multiply equation 4 into 2. So this will give you 4x1 plus 4x3 is equal to 6. Now this is equation 6. Now let us subtract this equation 6 from 5. So 5 minus 6 will give you what? So 6x1 minus 4x1 will give you 2x1. 4x3 minus 4x3, that will be 0. It will be cancelled. Now 2 minus 6, it will become minus 4. So this gives you x1 is equal to minus 2. Putting x1 is equal to minus 2 in equation 4, we have 2 into minus 2 plus 2x3 is equal to 3. So this gives you 2x3. Now here you'll get it as 2 into minus 2 will become minus 4. Minus 4, if you take it to the right hand side, then you'll get, it will become plus, so 4 plus 3 will become 7. So it gives you x3 is equal to 7 by 2. Now in this case, the basic solution will be the base is, okay, I'll write inside the bracket basic. That means x1 is equal to minus 2 and x3 is equal to 7 by 2. And the non-basic will be that one. What are the non-basic variables here are x2 and x4, and we set these two as 0. So non-basic is x2 equal to 0, x4 also equal to 0. Now this solution, the basic solution given by this one, x1 is equal to minus 2, x3 is equal to 7 by 2, and the non-basic x2 is equal to 0, x4 is equal to 0. This one is not a basic, it is not a basic feasible solution. It is not a basic feasible solution since x1 is equal to minus 2 is negative. Because to be a basic feasible solution, all the xi should be greater than or equal to 0. But in this particular case, we have x1 is equal to minus 2, a negative number which is less than 0. Therefore, the basic this basic solution here will not be a basic feasible solution because x1 is equal to minus 2. But it is a non-degenerate solution. Why it is non-degenerate in this case? Because none of the basic variable x1 and x3 equal to 0. x1 is not equal to 0, x3 also is not equal to 0. Therefore, it is a non-degenerate solution, not like in the case of first case. Why? Because in the first case, we have x1 is equal to 0. So therefore, where x1 is a basic variable. So it is a degenerate solution, but it is a basic feasible solution. But in this case, it is not a basic feasible solution, but it is a non-degenerate solution. So the rest also, that is for case 3, case 4, case 5 and case 6. For case 3, you consider b bar to be this 1, 2, 1, 6, 6, and for case 4, you consider b bar to be 6, 2, 4, 4. For the fifth case, you consider b bar to be 6, 1, 4, 6. And for the last one, you consider b bar is equal to 2, 1, 4, 6. That is for case 6. So you'll see that from the rest of the cases, that is case 3, 4, 5 and 6, you'll see that some of the solution will be a basic solution only, but not a feasible solution. And some of them will be a degenerate and non-degenerate solution, just like in case 1 and case 2. So case 4, case 3, case 5 and case 6 will be a repetition of either of case 1 and case 3. So you can try it by yourself and see it. What will be, which one from the four cases which gives you the basic feasible solution, and which cases does not give you the basic feasible solution. Hope it is clear now how to find a basic feasible solution.